Howdy y'all, today is January 5th and we're back for another daily problem of Leetcode. But first, let's do our daily type racer warm-up and get today started. Oh, not too bad today, not too bad. Let's go ahead and check out the daily problem. Minimum numbers of operations to something, something, something. Okay. Have I done this problem already? No. Okay. Minimum number of operations to move all balls to each box. You have n boxes. You are given a binary string box of length n. Okay. N boxes. Binary string. So that means like ones and zeros for a string. Box I is 0 if the ith box is empty. Ith is contains. Okay. This contains one ball. So it can either have 1 or 0. In one operation, you can move one ball from a box to an adjacent box. But box I is adjacent to box J. If the absolute value of the difference of I and J is equal to 1, note that after doing so, there may be more than one ball in some boxes. Return an array. Sorry. Return an array answer. Return an array answer of size n, where answer I is the minimum number of operations needed to move all the balls to the ith box. Each answer I is calculated considering the initial state of the boxes. So we have a ball in 1, 1 and 0. One ball from the second box to the first box. And you will have to move one ball from the first box to the second box. You will have to move one ball from the first box to the third box in one operation. So it's kind of like you're checking the distance of ones from zeros. Or not necessarily from zeros, but just all ones to this position. But only for adjacent positions. No, because this is saying 2 and 1. So these two would take 3 operations. Let's see, 1, 2. Yeah, so it's just the total distance movements, right? Whoa, oh, I don't know why I'm so tired. Okay, so 0. I don't know, hold on. I feel like this is going to be some kind of I don't know. I feel like this is some kind of summing values with the arrays, right? So if you have this here, how many sums of 1 going from right to left are there on the right side? Or on both sides? Could this be like a prefix suffix problem for all queries? So we would need the location of each one going across, right? So if we have a 1 here, we go here, then we have 2. It only counts if there's a 1. Hold on. Okay, so we know that the path from here to here for this one value is 1, 2, 3, 4, 5, right? And we know that this path is 4. So together is 9. So we have 1. Or do we just plus with the number of things, right? Going right to left. So if we're going right to left, when we are here, we have 1. Okay. When we are on to the next one, we are going left 1, running is 1. So there's going to be 2 things here. Plus the cost of moving the 1. So what, 3? No. Yeah, so we move 1. Now we need to move 2. But it takes 2 operations. So 1 operation, then 2 operations. Then this is going to be an additional 2 operations. This is going to be 3 operations. 3 and 3, right? 3, 6, 9, 12, 13. That's not quite right. Takes 1. Then 2. Oh, wait, I'm sorry. It takes 1 operation to move this ball to the next one, right? It takes 2 operations to move these 2 balls to the next one. 2 to do this. This adds 1. Now it takes 3 to go here. And then 3 to go here. So this doesn't have a value. So 3, 6, 9, 11. Going this way. Now, if we go up 1, say this value, we need to count the back value, which is 0 balls. So it's just 1 up, which is 3, 4, 5, 6, 7. Wait, why is it 8? Three. Oh, I'm sorry. 3, 4, 5, 6, 7, 8. Okay. Yeah, so it's just... And then 5 would be... So here is 5. Okay. Next up is 4. So to the left. Okay. Yeah, so we need some values going from right, and then we need some values going from left. Right? And if we were going left values, so this was going from right to left, we would need 0 to get from there, 0 to get from here. So we need 1. Let's do it like this. Okay, so we want 1 to get to here. And then 1 operation from go to here to here. And then 2 to get to here. Right. So if we want, say, this value, second to last, here, it takes 1 operation to get from the right side, and the sum of the left operations to get to this side. So should I hold the sums? This definitely feels like a prefix-suffix problem now. So I'm here. This is left to right. 1, 2, plus 1 is 3. Yeah. Okay, so yeah, this is definitely a prefix-suffix problem. Okay, and this is going to be boxes dot size minus 1. Right? Okay, so if we want to calculate going from left to right, we want to know how many it takes to get to the next thing. So if there is 1, so it's a running value, right? So say if running is 0. So we want to add the value here into running. So it would be 0 to get to here, 0 to get here. We have 1. Takes 1 to get to here. So anything running, add run to 1. Running again. And another one, which is 2. So it takes 2 to get to the next one. Is it running that I need? And I think I need running and sum. Okay, so we will go sum plus equals boxes I. Okay, so we're going to add whatever this value is. And then we want to add, what is it? we want to add sum to running, right? No, wait, hold on. So add 0, add 1. You add 1 again. Okay, yeah. So we were at that. So we're going to go running sum. And we're going to say boxes. Not boxes. Prefix. Running, right? Yes. Okay, and then suffix is going to be basically the reverse. I mean, I could do this at the same time if I want to add 2 more values. But I'm going to just do it in 2 loops. Dot size, I0, minus sum plus equal boxes I. Then we're going to go sum. Of course, this should actually be 1. We don't want to go to the last value. Okay. This is prefix I, doesn't hit the last value. This is suffix that doesn't hit the first value. So this value is actually going to be suffix I minus 1. Oh, wait, no. Okay, we start at the end, which is here. Yeah. Okay. So this should set us up for our suffix and prefix. So now we just need to calculate for each position, not including the position it's on. So we're going to need a vector int string, or vector int result, and it's going to be size of the string. We'll start at 0. And then we're going to iterate through. It really doesn't matter what we use. It's still the same size of the string. Okay, so we basically want the cost of the prefix plus the cost of the suffix, right? So if I equals 0, we basically want the suffix. So everything. So we're going to say result I equals suffix I, right? If I equals if I equals the last index, we'll just use the prefix. Else, the result of I is going to equal prefix I minus 1 plus suffix I plus 1. Right? Let's see. Prefix I equals running. Let me think. I shifted this over 1. It's 1 less length, right? Wait. Oh. This is, no, that should still work. Hold on. I minus 1 is the last value of boxes, which is here. Why is this not working? I know if I change this, it'd probably work. Wait. Oh, these are characters. Ah. Zero, 1, 1, 3. Oh, I'm not getting the first value correct. Here. Oh, should this just be this? I minus 1 suffix I. Oh, is it because I shifted over the suffix? Okay. Well, anyway. So if I use the prefix and suffix in this manner, it should be O of N. You scan once, scan twice, do the result. This is O of N. Referencing binding null pointer. Oh. This should just be 0. That's an interesting test case. If boxes.length equals 1. Let's say a little 1. 0. I didn't even... Oh. 0. Oh, wait. If we're going to do that, then if it's equal to 1, length equals 0, return null set. Yeah. I mean, this is going to work. Okay, what if there's 2? I mean, 2 technically should work. Yeah. Okay. And that's the daily problem. I'm actually kind of surprised I thought of prefix suffix as quickly as I did. I mean, not necessarily quickly, but I'm kind of surprised I was able to get to that the way I did. Anyway, so that's the problem today. Thank you for watching, and I hope you all have a wonderful day. Take it easy. Later.